right. Hello, everybody. Let me get rid of this lay overlay. Where is it? Right here. How's everyone doing? We have our amazing Emily with us.
Hello. I remember Avinov was
Hello.
at the Today in Global Hack Weeks earlier, so good to see you again.
Sweet. How was your first Global Hack Today in Global Hack Week stream, Emily?
It was good. It was fun. I got a new nickname. I think is Chicken Keeper. Spoiler alert, not
Oh,
fact.
nice. We need some pictures. We need proof.
For sure.
All right. Yeah, Emily Chicken Keeper. I'll keep that in mind. Um, Well, everybody, welcome to Global Hack Week Data Week. This is Emily's first ever technical stream, so let's show her some support in chat. Um, the topic of today is Reject CSV and JSON. We're going to learn about how to embrace the new world of Apache Parquet. And let me just introduce myself real quick. If you haven't met me, my name is Wei. I'm a coach here at Major League Hacking. A fun fact about me, not many people know this, but I don't mark my name or I add the registered trademark suffix to my name for nothing. It is actually a registered trademark with a US PTO. Definitely check it out if you're interested. And if you want to talk more about why I did it and what it's involved to get your name registered, hit me up on Discord.
Yeah, so I hope everyone appreciates my picture. I am too new to MLH to have the nice little doodle picture that Wei had, but there's my stand-in for now. My name is Emily. I'm a new coach, like we were talking about. I use she, her pronouns, and like we kind of spoiled before, I used to raise chickens. Unfortunately, Emily is not filed at the patent office. I think that one would be a little difficult to patent.
Well, Chicken Keeper, maybe. Emily the Chicken Keeper might be a good registered trademark.
That is true.
All right. And we want to just remind everybody to check in now so that you get your points. And there's a link. I've also sent it in chat. So be sure to head over and get checked in. There are also two advantages of checking in. First, you will get access to all the slides that we'll be using, as well as enter into a raffle for the surprise prize at the end. So you definitely don't want to miss it. Go ahead and head over to check in. All right, now with that, let's kind of go through some of the things that we're going to build today. We're going to demo today. Here is our session plan. First up, we're going to show everybody what is our Apache Parquet. We're going to tell you what that is, how it compares to JSON and CSV, as we alluded in the title. And we're going to create a Python Jupyter notebook and set up the environment. We're going to learn about how to interact with data in Parquet format, store and retrieve data, how it compares. And then lastly, we're going to interact with some Parquet data in the Python Jupyter notebook. And lastly, we're going to hand out a surprise prize. So stay tuned for that. Without further ado, let me hand it over to Emily, who's going to teach us about Apache Parquet.
Yeah, so I'm just going to go over a brief overview of Apache Parquet, do a little comparison to some other file formats that you might have heard of, and talk a little bit about what use cases there might be for Apache Parquet or when you might want to use it. Because I know it's something that maybe a lot of people might not have heard of. I know I didn't really hear about it before we were preparing this stream. So the first thing to know about Apache Parquet is that it is a file storage system. So a lot of times, all that means is just a way to store data. Typically, we store data. We can think of it in terms of rows, like this example on the left here, where if we're storing things about people, let's say John, Mike, and Sally, each row corresponds to a person. So we think about it logically in that row format. But what Parquet does is that it actually flip flops it so that it stores it in column format. So it's still the same information, but you can see here that instead of grouping each person with their associated like numbers and data, we're actually grouping each column together. So we have in this case, that 1, 2, 3, let's say that's like their ranking or something. We're actually storing those together rather than associating John with rank 1 and grade 4.1 or something like that. So this might seem a little abstract right now, but if we dive into it a little bit more, so the database grows the same way. I guess it depends how you think about it, right? Because if you visualize it in like a horizontal format, then you could say that. But the main thing is how the data is grouped, if that makes sense, right? So I guess for an example, on this slide, you can see that we still have the data growing vertically. When we add a new customer, it'll be a row 4 at the bottom, but we're just logically grouping them differently. So it's just kind of a way to approach it in a different way. Yeah, so for a little bit of more in-depth overview on why you might use column-based or row-based file format, these two different systems. They are both definitely very useful, just kind of different use cases. So on the left, we have the row-based file format that we were talking about before. This is kind of, I think, what people most intuitively think of when they think about databases. And that makes sense because row-based data formats are used a lot for transactional databases, which means things where you're working with complete rows. So if you're working on some sort of application where users are adding things to a database and you're trying to collect data on things being added over time, that would be a good use case for a row-based file format. And that is a lot of common use cases, so that makes sense. Because of that, it is optimized for insertion, updating, and deleting operations, things where you're adding new entries to the database. Whereas in the column-based format, a lot of times it's working with big data, right? So there's this term, I don't know if you guys have heard, like a data lake or a data warehouse, which is basically just a giant pool, like the word lake implies, of data that you're trying to analyze in some way. So a lot of times this involves working with full columns. Like for instance, if we take this example here with Alice, Bob, and Charlie, let's say we had like 10,000 people here. And on the left, if we were using a row-based file format, it might make sense if the use case was tracking people who log into an application or something. But if we were a business analytics company or something and we wanted to study the average age of everyone who's logged in, then maybe a column-based file format would make more sense because we're trying to query the information just on that one age column. And in the row-based file format, this would be difficult because in order to get all that age information, since it's row-based and everything is bundled together by rows, even if I just want to look at the age, I have to pull in all of the data, right? So when I can't just grab the age 30, I would have to grab that whole row. So that's the big reason why column-based file formats are typically used for working and aggregating across columns and those really large-scale read operations. And then another big aspect of column-based file formats is that they often require less storage space. So Wei will actually demonstrate this in a little bit, but because things are column-based, you're actually able to compress things in different ways in order to use less storage space when you're actually storing the data as well.
Perfect. Yeah. We do have a question in chat. What does Apache do? So Apache, if you have worked with Apache Web Server, that is one of their original products, Apache Web Server, that a lot of the web is running on right now. Since then, Apache Software Foundation has grew so much. It is a volunteer-based, like open source project organization, I would say. They host a ton of great open source projects, which include Parquet, is one of them. You might have heard of some of the other ones, Apache Spark, Apache Airflow, maybe Apache Kafka. Those are all the different software that are currently hosted under Apache Software Foundation. So a ton of great open source projects they're sponsoring and working with. We have a little feedback, Emily. You can speak a little bit slower. We don't need to rush at all. We have 2 hours. And very good material. Let's keep going.
Yeah, for sure. Just to provide a little bit of context, for row-based file formats, a lot of things that, like we mentioned, are pretty typically use row-based file formats. So, for instance, CSV, like we advertised, and a lot of relational databases. If anyone has worked with databases like MySQL or PostgreSQL, a lot of the most common examples. And then for column-based file formats, a lot of these might be things that you are less familiar with. At least I know I'm a bit less familiar with. I think a lot of it might be because since they're working with big data, it's oftentimes more of an industry standard because like companies are working with big data. But for some examples of that, obviously Parquet. Amazon has a product called Redshift. I know Snowflake is a big one, and then Google has one called BigQuery, which, as it implies, allows you to make big queries. Yeah, it's super cool. So uh, that's actually a great thing to bring up because Parquet actually extends the column format a little bit. It does a little bit more to actually make it even more powerful. There's something called chunking, and that's exactly what you might imagine it is. So on the left here, we have um, what the data might look like in that column format. As we were talking about before, things are sorted into those vertical columns. But Parquet actually does chunking to break this up into chunks. So it's not just storing one full column, it's actually storing maybe, let's say, the first 5 columns of row A, and then row B, and then row C. So in this image on the right here, you could see what that might look like in this example. Here they're just chunking it into the first 3 rows and then the first 2 rows. So rather than having A1 through A5 first, you can see that they just do the columns for 1 through 3 first and then 4 through 5 first. And this is really powerful in a number of ways. We'll talk a little bit about that here. Yeah, Redshift. I haven't personally worked with Redshift, but I know that it is also a pretty popular one. Um, I'm excited for Wei's demo in a bit to show how much faster Parquet is because it's really, really cool. I was surprised at how much faster it was for sure. But to give an overview of summarizing all that and then also talking a little bit about use cases for Parquet, one big thing that we were talking about is performance. So because you're able to grab full columns very quickly, it is highly performant for use cases where you're working across columns. And also, like we were talking about, since you don't have to grab the full row of data, you can just hone in on a specific column. There's better I/O or input-output performance because you're grabbing less stuff when you're working with it. Another example or another advantage is that Parquet, like we were talking about, is more efficient for storage. So that column-based storage allows things to be stored better. And Parquet in particular is also compatible with a lot of common compression methods. So not to get too into the weeds, but things like Snappy or gzip, if anyone has heard of those. But it's very easy to compress the data. Another thing is that Parquet is very flexible in data. So in the example before, let's say we have a column of age and like a grade. If you then wanted to add another column, Parquet actually allows you to do that very easily. And you can also change the type of the data of a column. A lot of times in databases that can be difficult to do because if we're row based and then you add a new column, all of a sudden all the rows before are gonna have missing values for that. There might be issues with that, but Parquet makes that super easy. And then finally, the last big advantage of Parquet is that it is scalable. And this is kind of what we were talking about before in terms of it being used a lot in industry. It is very, very applicable to large scale data, and Parquet in particular actually allows for parallelism, where a bunch of different machines can work on different parts of the same data if you have a really huge database. And that is an example of why the chunking that we were talking about before is very effective. So yeah, with that, I'll pass it off to Wei to dive a little bit into Parquet.
Awesome. Thank you, Emily, for that overview. We're going to get into a little bit more practical uses of Parquet, and we're going to start with finding a data set for our demo. We're going to learn about how to set up the environment to use Parquet, and then Emily is going to come back and show us what are some things you can do in Python with Parquet data. Let me know in chat, everybody, what are some websites you typically go to find some data sets? I've used a few throughout the years, but I'd love to learn from you and see what places have good data sets. All right, we have some comments in chat. Thank you very much. So Cal is a very good one. That's indeed the one that I have used the most. So we'll probably head over there to find some data sets. We also have, thank you, Shemri, Kaggle, Open Data, NASA, very good data providers there. Let me go ahead and share my screen. Has anyone in chat worked with AWS S3 before? Let me know. I'm thinking about using S3 to store our data set. So for now, let me go ahead and share my screen and pop it onto the page here. I have logged into my AWS account, and I'm going to create an S3 bucket to store our data sets, and then we'll work with that data set throughout this demo. So we have a newcomer to AWS, S3. This is perfect. This is a great way to learn. S3 is what's called a object storage, and they make storing objects super easy. So objects can be a file, it can be a blob, it can be chunks. So today we're going to create a S3 bucket and store some files. And by the way, S3 stands for Simple Storage Service, Amazon Simple Storage Service. So I'll create a new bucket. I'm going to pick US East 1 as an example. So Northern Virginia, general purpose. And for the bucket, we'll just do GHW data Parquet. So that will be our bucket name, GHW data Parquet. And we can keep public access blocked for now. We'll use keys to access the files. And just like that, we'll create the bucket. Perfect.
Hey, have you heard of Earth Data? I've never actually heard of that one.
Earth Data, I have not heard of it. That's very good. We're learning, so I'll check it out after the stream. Thank you. S3 is the best. Yes. Let's do it. So we have GHW data Parquet. That's our bucket name, and this is in US East 1. All right, let's head over there. And there are no files currently. That's fine. And then here comes the second step, which is we need to get access key and access secrets so that we can access files in this bucket securely. With that, I'm going to head over to the IAM, which stands for something Infrastructure Access Manager, I'm guessing. Let's see. IAM. No, I was completely wrong. I was making it up. Identity and access management. That sounds more like it. And with that, I'm going to create a new user. And we'll say GHW data Parquet user. Okay, and user type. Yeah, so we don't need user type. No, I didn't. Is that where we need to create it? Let me just take a look. No. All right. Let me see. Oh, I don't need to provide user with access to the console because this is going to be used programmatically. And I'm just going to attach the policy called S3 full access, Amazon S3 full access, so that this user we're going to create will have permission to all the files, read and write all the files, as well as all the permissions related to S3, and create user. And just like that, a user has been created, and then we're going to create a security key, access key. So I'll do application outside of AWS. All right, for a demo, Apache Parquet demo at Global Hack Week. All right, and just like that, we have our access key and secret. We'll keep here on this page for now. Let me check back in chat. All right, so here's the link to Earth Data. Thank you for sharing. I'll definitely check it out. All right, next up, let's open up a Jupyter notebook, as I mentioned at the beginning. So here's the Jupyter notebook file that we have created for this demo. We'll share it later. And there are a few things that we need to do. First up, because there are some limitations in Jupyter Notebook, we're going to set the AWS keys in the environment variables directly in the code block. So we'll import OS, and then the command to set environment variables is env iron. Okay. And there are a couple AWS keys that we need to set. The first one is called AWS Access Key ID. Okay, so looks like Google Gemini already knows what I'm about to do. So I don't have to type them out manually. All right, so we have 3 environment variables now, and let's populate them. The first one is the key ID. We'll grab them from here, access key ID. The second one is the secret, copy. And then the last one is the region. We'll just do default US East 1. Okay, with that, we have the environment variables set up perfectly. Maybe we should add a text block up there and say set up environment. Okay. Perfect. All right, next up, let's install some packages. There are a few packages we need to install. The first one is pandas. Has anyone used pandas before? What are your thoughts on pandas? Emily, have you used pandas before?
I have, yeah. Pandas is very powerful, yeah.
Yeah, it makes data manipulation super easy, super efficient in Python. All right, we got some yeses in chat. Thank you for commenting and letting us know that you're familiar with pandas. And then next up, we're going to install PyArrow. This is a utility that lets you very easily integrate with Apache Parquet format. We won't really see this very much because PyArrow is the default in many cases when working with Parquet. So we just want to install the package so we have it. And then lastly, we're going to install a package called S3FS with the quiet flag so we don't see a bunch of outputs, and hit run. So S3FS makes it possible for you to interact with a S3 object storage bucket, just like you would a file system. Makes it super easy, and you'll see very, very shortly in my demo. All right, while we wait for this command to install, let me create another code block and just maybe write a very simple command, or maybe initialize a simple data object and data frame using pandas. So this is how you would import pandas into your application, and we'll just create a very, very simple data structure. So for example, we can do column 1 with data 1, 2, 3, and column 2 with data 2, 3, 4, something like that. And you can initialize a data frame from pandas using this command that Gemini already populated for me, df equals pd.dataframe. And then lastly, you can print out some entries in this data frame using df.head run. And just like that, you see our column 1, 1, 2, 3, column 2, 2, 3, 4 in a data frame format. So this is the most bare bones of a pandas data frame. All right, cool. Give me a thumbs up if you're following along. So we have some yeses on pandas. Thank you. Pandas for data manipulation, indeed. Thank you. Thank you for the comment. You go to club too much. Your phone knows. All right, let's go. Let's go. All right. So up until this point, we've set up our AWS keys. We installed all the necessary dependencies. And next up, let's create a new code block, and let's save data to S3. So let's convert this data frame into a CSV. We'll do CSV, JSON, and then lastly, we're going to do Parquet. So let's do to CSV for now. And because we installed S3FS, it's super, super easy to write to S3. All you have to do is specify a file path that starts with S3 and your bucket name, which is GHW, data, Parquet, and then lastly, your file name. So I'll just do a simple data.csv. Okay. Save simple data.csv to S3. All right, fingers crossed. I'm hoping this works. Run. Executing. You see on the bottom. Okay, great. Access denied.
Oh, I think this is the permissions issue that you have.
Yeah, I might need to. Yeah, I don't remember if I ran this. So let me just run all the commands one more time. And then we'll go figure out the permission issue if that doesn't work. We're just running everything one more time and then running this. Okay, it doesn't work. Great. Access denied. So the good thing is I do have a backup bucket. Did anyone notice anything I've done that could have caused this error?
When we were running through it before, I think there was a permission that you had to set in order for it to be accessible.
Yeah. So you're talking about on the bucket itself?
I think so.
Okay.
Not sure. I think under access control.
Yeah, this thing. Okay, let's just try this one more time. If it doesn't work, we have our other bucket. So yeah, block all public access. That might be the problem. Save. Let's try. S3 permissioning is very, very strict because they've, as you know, there has been a lot of hacks in recent years that have caused issues. So let's see. Bucket owner preferred. I'm gonna try this one more time, and if it doesn't work, we'll do something different. So for now, Yeah, for now, let's give permissions to everyone public access. That's to read and list the object, not really to write it. But let's see.
Wait, Abhinav might be hacking into your S3 bucket here.
That's fine. I don't have any data. Please hack into my bucket. All right. So let's create a new security. Maybe I'll put a secret flag there. So whoever gets it gets the surprise prize. I don't know. All right. Let's create a new key just in case. All right. Let's create a new key. Secret access key, default region, that all looks good, and then the secret key. Okay. Run. Oh, it's already installed. We don't really have to run that again. One more time. Did I spell this wrong, by the way? GHW did a Parquet.
No, that looks right.
Looks correct? All right. Okay, live demo. We anticipated this, so let's move to our backup bucket, which is, let's go to S3. We'll use the MLH GHW 24 bucket that I've been playing with, and I'll delete all the data here for now. Delete.
It's good advertising for AWS security.
Yes, very secure. Very secure. All right. So we now have a bucket that is empty, and I'm just going to copy over my keys from my other demo. So we will copy over the environment variables here, and the bucket name is MLH GHW24. All right, so we're going to load the environment variables and run this one more time. Great. Okay. Did you have to set up some permissioning to access external files?
I didn't change anything.
Okay. Well, I've just meant in your other.
No, I didn't change any of the default. Yeah.
Okay. Okay, I'm running it on my other notebook here. Just give us 1 second. How's your stream? What's your experience working with S3? Have you encountered access issues, permission issues in the past? I'd love to know.
I know access stuff is always finicky. It's always just like one small button that you have to press somewhere.
Yeah, indeed. Okay, so we do have our other notebook. Let me just share that real quick with you. Okay. So here's a notebook that we have been working with, and we'll keep going with this. So this is the same thing, right? We imported OS, and we set up some environment variables for our bucket, and we created a very similar simple data frame. And now there are a few things we can do. I'll just add a few more code blocks here so we can continue.
I think we're still looking at the original notebook.
Oh, okay. Yeah, thanks for letting me know I'm on a different tab now. All right, so here, this is the right tab. We have set up the operating system, imported the OS package, set up the environment variables, installed the packages. And then let's let's keep going. So we'll copy the code that we had, which is saving the simple data to S3. And Pandas actually has a couple more like very, very useful commands that you can use. So one of them is to CSV that we're using right now. And we can also save it to JSON in Parquet directly. So we can do something like data.csv to JSON. And then lastly, we can do save simple JSON to S3. And then we can do simple data.parquet to S3. All right, so let's do to JSON. We'll just use the same path, but with JSON suffix. And lastly, we'll do to Parquet. And just like that, we can go ahead and run this. Please work. Fingers crossed.
Mm-hmm.
All right, done. 3 seconds. Great. And now if we go back to our bucket and refresh, you'll see a number of files here. Some of them are from before. So let me just go ahead and delete everything and upload one more time so there are no confusion. All right, so I delete all the objects. I'm going to run one more time to save those 3 files. And boom. So as you can see, it is super easy. Using Pandas, we're able to save a file to S3 through the F3 FS package, interacting with it like a file system, and we have 3 files now. One thing to keep in mind, though, is so CSV has the smallest file size, as you can see, only 35 bytes. JSON is a little bit larger because in JSON, as you know, a lot of the keys are repeated. And lastly, Parquet has the largest size, which is 2.2 KB. You might not want to use it after seeing it, but don't worry. This is just because Parquet has a set overhead for any given data. And because the data that we're storing is so small, the overhead versus the whole file size is slightly larger. You'll see the benefits very, very shortly. Okay, any questions about this? How to save data frame to S3 in 3 different formats? Let us know in chat. Give me a thumbs up if it all looks good to you.
Looks like Ahmed was saying before that he's used S3 with Hadoop and PySpark. Those are actually, a lot of times, Parquet is very compatible with those, especially PySpark. But yeah, very cool.
Awesome, awesome. Thank you for sharing, Ahmed. And yeah, thank you for the thumbs up. Why the higher overhead for memory for Parquet? So Parquet structures things a little bit differently, and there is a set number of overhead. I can send you more information on what that consists of, but it is negligible because a lot of times the overhead versus the data is like it's just a very, very small fraction of the overall data.
A lot of it is just like metadata that it stores at the top and bottom of columns. So nothing crazy. Yeah.
I see. Yeah. Thank you. Thank you for sharing that. Thanks for the question. All right. Next up, let's go ahead and find a data set. Save failed multiple times. Okay. Has been changed as an extension. Overwrite existing changes. Well, I'll keep going. Maybe I should refresh actually, so that we don't cause any issues when Emily is going to demo her part. Okay. All right. Let's just keep going. Let me delete this block. All right, cool. All right, let's keep going. So we talked about a lot of websites where we can find large data sets. Kaggle is one of them. as you can see here, they have a whole datasets page. Let me actually send the link in chat. Right here, this is where we are. We have a comment here. I don't know what you're trying to say there. Teacher asked what you learned in your coding class. I told how to JS. Okay. All right. So with this data sets page, you can access a lot of different types of data, and they are all free for you to download. One example is like you can even filter by the file type you're looking for and file size. So if you want information, for example, for movies, you can do movies, and all the movie data sets are here. If you want data sets on music, we can find a ton of amazing data sets on music. And today, we're going to pick one data set in particular that we found that has some very interesting attributes. That is this data set, 1 million Spotify tracks, and they're all tagged accordingly. So as you can see here, these are the preview. Let me actually hit the download button right now so we can have it downloading while we wait. Okay, it's downloading. Perfect. And you can look through the data in different views. So the detail view, you can see we have available markets, duration, explicit, ID, local, popularity, and so much more. So a lot of very useful information for us to be able to manipulate and visualize, right? So just like that, I hit the download button and I'm now downloading the files. I think it's finished downloading. Yep. And for now, I'm going to upload this file onto my S3 bucket. So we have the 3 simple data files from before. We're going to upload another file that's going to be called testalbuminfo.csv. Okay. Let's see how fast my internet is. 1.1, 1.4 megabytes per second. It's picking up a little bit. All right, in the meantime, we have the file name. So I'm going to show you how we can interact with this data. Okay. Let me head over to my other page here. Okay, so because our file that we just uploaded is S3, is CSV, let's load this file onto our Jupyter Notebook by using this command. I'm going to just leave a comment here. Load CSV to data frame, pandas data frame. And we can do that by using df equals pd.readcsv. All right, so just like that, we'll change the file name to testalbuminfo.csv. So what this will do is it will go out to S3 bucket, grab this file, download the file, and parse it and load it into a pandas data frame. And using df.head command, we can preview the first 5 lines or so of the record. So I'm going to let me just double check the file has been uploaded correctly. That is here. Yep, upload successful. So I'm going to hit this run. And it's executing. It's going to take maybe a few more seconds here to load the whole file into Google Colab. And then it's going to parse that data. Okay, so this file is a little bit larger. Let me just double check how big it is. Let's go back to S3. And as you can see here, this file is actually 544 megabytes. That's not a small file. Of course, there are bigger files, but it does take a little bit of time to transfer it. Okay, done. And as you can see, we have loaded the first 5 rows of this CSV file. And we see all the columns that we were talking about. Okay, give me a thumbs up if it looks good to you. In the meantime, let me keep going. Store large data set as JSON. So we already learned how to do that. Let's just, let's have, what is it called? Gemini help us real quick. So we're going to use the df.toJSON property, and it's going to write the JSON information to the S3 bucket. Once again, this is going to take a little bit of time. What it's doing behind the scenes is the Colab is taking the CSV, it loaded into a data frame, and the data frame is now converting that into a JSON format and then saving it back to S3 with this file path. So this might take a little bit longer. And in the meantime, let's also write the code to store the large data set as Parquet format. So we'll run this right after the JSON command is done. Zimmy Hacks, thank you so much for your thumbs up. All right, it looks like it's done. It took 47 seconds. And then let's run this to Parquet command and see how long that takes. Eight seconds. Do you see the difference? Do you see the difference? Now, if we go back to our S3 bucket, this is where we will see a very clear view of all the files. So as you can see, we have our original CSV, that's 544 megabytes. The JSON is 600 megabytes and change. But when we store the exact same amount of data in Parquet format, it is only 75 megabytes. Isn't that crazy? Let me just do a quick calculation. That's over 85% cut from the file size. That's only like 15% of the file size, which is crazy. Just imagine if you were in a big company with tons and tons and tons of data, how much this can save you.
Especially if it's like gigabytes, terabytes, like this is just megabytes.
Exactly. Yeah, this is just megabytes. Yeah, if you think about it, this will really save so much. And it also helps with, it's also faster too. So not only is it saving storage, it also helps with the processing speed. All right, cool. So I think we learned how to set up the environment. We had a little bit of hiccup with S3, but we were able to use our existing S3 bucket and Google Colab page to get that to work. Let me go ahead and save this file for Emily. And if you want to refresh real quick, it should have the data and everything. You might have to load it again, but yeah, we learned about how to store data in Parquet format using pandas data frames. And then next up, I'm going to hand it over to Emily, who's going to show us a little bit about how to interact with Parquet data.
Yeah, so here, let me just grab the screen.
Hello, Donald Trump. Welcome.
All right, cool. So just picking up where we left off. Just kind of running all these things so that they're all loaded on my end. And we're going to be working with some pretty common data analysis, data visualization tools that you might see in Python. Um, I guess before we get started, I'll quickly mention that there are a lot of ways to actually handle Parquet data. Today we're doing this just because it's one of the more simple ways, and it's more intuitive a lot of times to just work with like things like pandas. But Apache actually has products, like I know we were talking about earlier, PySpark, that work directly with the Parquet data really well. So you might see some of those things out in the wild as well. Okay. Or I guess I don't actually have to run these. Let me stop that.
Yeah, you should have the data already loaded. You don't have to overwrite the JSON and Parquet formats. While Emily's getting set up, just a reminder, please check in. That's how we will pull raffle winners. And that's also where you will get access to our slide deck and the Google Colab file after the session.
Is the... Oh, here it is. Okay.
All right, so I see it's still trying to save the JSON. It will take, if it's the same as last time, it will take about 47 seconds.
Okay. All right. I think
I forgot about that part. Yeah, so that's how you would load the Parquet data back into your Python data frame.
Yeah. So here, I already ran this for the CSV, but we can do the same for the other formats. But since we're working with the Parquet, we'll pick up from there. Pandas actually works really well with Parquet. I think this is actually a fairly new method that they have, the read Parquet to integrate with Parquet. But let's see, I'm gonna import pandas in case that didn't load, and then we'll grab this Parquet file that Wei made for us. And then this .head that we've been working with should just let us see the first few rows of the data just to verify that we're looking at the right stuff. Cool, yeah. So we have a few albums.
Oh, that was so much faster than our initial load of the CSV.
Yeah, we're advertising it very well. Cool. So I'm gonna go through a little bit of kind of what the general process might look like for doing some very simple data exploration. We won't go too in depth today, just because we're focusing primarily on the Parquet storage and things like that. But one of the first steps that you might want to do when looking at data is to understand what your data looks like, whether that's like some trends across the data, or even just like what are the columns of my data, what are the data types. So in a data frame, they have very nice methods that allow you to do that. So we'll start with Parquet, one called .describe, and you might be able to guess what that does. It just gives you a little bit of detail into like an overview of your data. So in this case, we can see the count, meaning the number of entries for each of these columns. Luckily, they're all the same number. That makes sense. And then we can see like mean of each column, standard deviation, minimum. In some contexts, that might be more relevant than others, but just a good way to get an initial overview. And then we'll run a few other things. So we can do .d types. So this is a good way to understand what the data you're working with is. So D types gives us the type of all of our columns in our data frame. So here we can see that we have available markets, which is some sort of object. In this case, it's actually this array. Uh, we have some Boolean values like whether or not it's explicit, whether or not it's local. So those are just true falses. And then, of course, there are some things that are numbers, like popularity. It's given a numerical score. Album total tracks, the number of tracks on the album. So now we have a little bit of context of what we're looking at with our data. And then one last thing that is good to do is this is null. And that is kind of more of a check to make sure that there's not too much like null entries in your data, stuff like that. So we can see here there are a few null entries for the name and the album name. So there is some finicky data, but now we have kind of a general understanding of our data is pretty clean for the most part. We're working with a bunch of different categories on labeling different albums, musical albums. And now we can go ahead and do a little bit of exploration. So let's add a cell here. Cool. So I know when I was looking at this, I thought that popularity might be an interesting thing to look at. So we can do a histogram or something to first visualize it and understand what that popularity data looks like across all of the tracks. So for plotting histograms, there's something called matplotlib. I don't know if you guys have worked with that. You can share in chat if you have. It's definitely a very common one. And if people are unfamiliar with Python, this like as PLT is just kind of a way to give PyPlot a nickname because I'm too lazy to type it out every time. So um, we can do cf dot. All right. So on this line, I'm grabbing that popularity column of our data frame, and then I'm telling it that I want to make a histogram with bins is 20. Bins is, if you guys have seen a histogram, um, the number of these different like bars that we want to split the data into, right? So we'll just go with 20, not too large, not too small. Um, and if we just run this, it should already work, but we want to maybe give it some labels. You know, in school, they always say it's good to label your charts, but we also want to understand what we're looking at. So we can do title. We'll call it distribution of popularity. And then we'll also label our axes. So that's just X label and Y label for the X and Y axis. So our X label should be popularity, and then our Y label will be, just say like count. And then that'll give us a little bit nicer of a histogram. So already you can tell why this is a super useful thing to do, just doing a general visualization, because we have so many unpopular tracks. So if I want to work with tracks for some project or something, maybe tracks that are in this bottom area here are not that relevant to me. And you can see they make up a majority of the data. So maybe I want to get rid of some of those less popular tracks because they're probably a lot of like more random things that aren't really relevant to music in general. So we can do that by creating a new data frame. We'll call it, let's say, popular. We'll say like filtered data frame maybe. You'll see my bad variable naming already. um, so what we're doing here is we're just making a new data frame that is the tracks that have a popularity of above, let's say like 5. So cutting off this first bar here. So we're going to grab that popularity column, and Python and pandas is great because you can just do something like this. So this is grabbing all of the rows of the original data frame where the popularity value is greater than 5. And then we're storing that in a new data frame called filtered df. So we'll just do a check on what that looks like. So you can see now the popularity values are all above 5. And if we want, we can even plot it again just to look at. Hopefully, our histogram will no longer have that big bar at the left. Cool. So you can see now our histogram makes a little bit more sense. We can understand a little bit more what's going on with our popularity. So here, this big bar was so big that it was flattening everything else. But now we can see there's some like spikes and dips. So that might be something that you're doing just in the process of like cleaning your data to make sure that you're only grabbing things that are relevant to you, and also like doing a little bit of initial visualization. So another thing that we can do is do some different analysis and different stats. So one thing that we might want to do when we're working with data or doing like data analytics or something like that is test a hypothesis, right? So if we go back to our original columns here, we can see the types of data that we have, and maybe we want to hypothesize that maybe if a song is more popular, what would be a good hypothesis? If the, or let's say like maybe if an album has a higher number of total tracks, the duration should be longer, right? And I hypothesize that because if there's more tracks, it probably will have a longer total length. So we'll see if that's the case. Cool. So we'll create a variable called correlation. And then again, we're working with our filtered data frame with those unpopular tracks removed. And we're going to grab the album total tracks. And then we can do this .core, which stands for correlation. And we want to compare that to our other column, which is duration. So I don't know how familiar people are with statistics. Personally, I'm not a huge statistics person, to be honest. But correlation is essentially looking at two different columns or two different categories of data and then studying how well they tied together. So, for instance, as one increases, the other increases, that would be a high correlation. But if there's no correlation, that means that it's all kind of random. There's no real like correspondence or pattern between the two. So let's take a look at what the correlation here is. I believe the results are disappointing. Yeah, so very low correlation between those two. So if you're testing a hypothesis of let's say is number of tracks in an album correlated with duration. Um, that would be a very simple way to test that. There are a lot of other statistical tests that you can do that go way more in depth, of course, but just kind of working with data here, seeing some different things we can do with it. Cool. So maybe we want to visualize this as well. So we can make another chart. In this case, maybe a scatter chart would make sense, where you have one axis on the left, one axis on the bottom, and then we can see if there's like clusters of things or like a clear line or anything like that. Um, for this, we're still going to use that matplotlib from before. Um, so some of this is just boilerplate code, to be honest. But like for instance, this first line is just telling it how big of a chart we want to make. But for this, we'll actually need um, something new called Seaborns. So I don't know if people have worked with Seaborn, but it allows you to do some more in-depth things than just maybe like basic pandas would offer. So there's a lot of different like tests, statistical analysis that you can do, but we'll grab that. And then, yeah, so for our plot, we're going to use reg plot. And then we have to tell it what our data is. So our x-axis we'll label as duration. And then our y-axis will be our other data that we're trying to study, which is album total tracks. And then we just have to pass in some other things. So our data is our filtered data frame, scatter AWS. This is more of like a mathematical thing. So if any of you are math inclined people, you'll probably understand that better than me. But that's just something that is like a threshold for how we want to plot our scatter plot. And we'll make it like, why not like red? I don't know. Cool.
We have a quick comment in chat.
Mm-hmm. Would a correlation matrix be a good visualization for this? Yeah, so that could potentially work out really well, actually. We have a few numerical columns. One thing that might be difficult is that you might want, typically, like for a correlation matrix, for people who are unfamiliar, that's a way to visualize like all the correlations between, if you have like 10 different columns or something like that. It just has like typically maybe darker spots where there's a higher correlation and lighter spots where there's a lower correlation. Heat map is very similar. We could definitely do that in this case. We can look into that next for sure. But I would say in this case I might lean away from it just because I have less numerical data. A correlation matrix might be a better fit for a case where you have a lot of different columns of data that you're trying to understand at large. But if you're testing specific hypotheses, you can plot those specific columns. But yeah, that's a really good suggestion for sure. Cool. So then let's keep going with this. Again, we'll need a lot of this same like boilerplate stuff from before. So title, X label, Y label. In this case, it will be like popularity versus total, or what is it? Duration versus total number of tracks. Okay. Our x-axis will be duration in milliseconds. Y-axis will be album total tracks. We'll give it a grid by doing plt.grid. That way it just looks a little bit nicer. And then we'll call plt.show. On a Jupyter notebook, it's actually nice because sometimes it will like automatically show things even if you don't call show. Like you can see in this example of the histogram, we didn't actually call it, but it still visualized it for us. Here, I think it's just taking a second to work through all the data and plot it all. So we'll give it a second. Yeah. Right. And in the meantime, we can maybe look at some other things that we can do. So let's say that you're looking at this data and maybe you're just kind of curious about like what the data is. Maybe I don't really have a particular hypothesis, but maybe I'm like, oh, this is a lot of Spotify tracks. What are some like of the most popular tracks in this database? So we can also do something like that. And we can get to that next. So most popular tracks. Okay, but if we backtrack here, we can see that we have our scatter plot. In this case, the scatter plot is a little bit weird. We have some outliers on both axes, so some that are very, very long, and some that have a lot of total tracks. So I was looking at this earlier, and I, my kind of guess is that since this is from Spotify, people can upload like all sorts of things to Spotify. So I'm sure that people have uploaded some weird outlier songs. But yeah, so a way to kind of visualize what those two categories look like in comparison to each other. This red line that you see here is this KWS. That is our trend line. Um, Typically, if you had a case where the data was very correlated, that would be like the dots are all kind of following like a sort of pattern like that. Our trend line would follow the data a little bit better. But again, in this case, our data is a bit weird. So the trend line is also a little bit weird. But that is generally the process that would look like. So now if we move on to what we were talking about before, um, if I just want to like explore this data, let's say I'm not necessarily doing analysis on it or plotting charts, but I just want to say, I'm just curious what the most popular tracks are here. Can do a new um, section on this. Let's say like most popular tracks. And for a data frame, you can actually do this sort values, which, as the name implies, allows you to sort by a specific column. In this case, we'll sort by popularity. It automatically sorts in ascending order, meaning that the lowest values will be first, but we don't really care about the least popular tracks because, as we established, there's a lot of those like zero popularity tracks, right? So we'll want to do ascending. It's false. And actually, this should be the filtered database. Oh, filtered DF, not DF filtered. Okay. And we'll just grab the top like 10. And we'll see what that looks like. So hopefully this should have some pretty popular things. Okay, so we see the names here. Let's see. End of beginning, beautiful things, greedy, cruel summer. Okay, so some pretty popular albums. I thought this one was funny when I was looking at it earlier. Clean baby, sleep, white noise. There must be a lot of parents who are playing that one for their kids. Um, but let's say we want to print this a little bit more cleanly. Just because you can tell that since it's printing everything and it can't fit it on one row, it's a little bit messy to look at. So we can just print um, the top 10 names. Cool. So there's another use case of data like this. I guess one thing to keep in mind through all of these different examples is that, like we were talking about initially with Parquet, a lot of the things that you're going to do are like data analysis, studying trends, things like that. So you'll notice a lot of the stuff that we've been doing has been working across entire columns rather than adding a row to the data or changing a particular item, something like that. We're trying to study trends at large in a big data set. Yeah, so there's another use case. Cool. Is there anything that you guys would be interested in looking into with this database? Anything that you might think of to explore? I know that was kind of some of the more like general use cases that I prepared, but if there's something you guys find interesting, we can take a try.
All right, that was wonderful. We do have one question in chat from Void. Can we also store things like image, video? I'm assuming you're referring to Parquet. To answer that, if you're asking about Parquet, yes, you can store a lot of different types of big data of any kind. You can store structured data, you can store images, videos, documents, and other data that can be represented in a array bytes format. So it might not be the most efficient way to do so. Oh, we're stepping on each other. So thank you for your question. Hope that clarified a little bit. If you haven't checked in, by the way, please go to this link to check in and enter our raffle. If you have checked in, please comment if you have any questions you'd like us to answer. If you want to, if everyone can just comment one thing you learned today, summarize one sentence, like one takeaway from this session that you learned. Let us know in chat. Someone learned nothing. Learn the minus sign, or is that an underscore? All right, I think everyone's typing, and no, I think I think how do I say this? Oivi messaged before I asked everybody to comment. Parquet is
Yes.
greater than yes.
Reject CSV and JSON.
Yes, exactly. Oh, we have this one. The Parquet seems to be much easier than when using data sets.
Yeah, for sure.
More about S3. Yes, we learned a little bit about S3. and you watch me struggle a little bit with it. I'll have to figure out what the problem is. I'm suspecting like Google Colab is preventing network access or something. We'll have to figure that out after. No question. All right, thank you so much for letting us know. You learned whatever we taught. That's a good one. All right. Do you want to read this, Emily?
Yeah, so yeah, we had the IAM permissions issues for sure. Glad we were able to demonstrate some of that on the fly, but yeah.
Yeah, yeah. We'll share the Jupyter notebook afterwards, but I used the right commands, so I really don't know what the problem is. I'm just suspecting I'm using the NLH Google account that has some permission issues with connecting to AWS, but I'll figure it out. All right. Yeah, so thank you everybody for coming. Let's do the key takeaways and then we'll do the surprise prize, all right? So here are some of the key takeaways for this session. We learned from Emily about what Parquet is, introduction to Parquet, how it stores data differently, how it organizes data, also how efficient it is. We also worked with AWS S3 to store a data set that we downloaded from Kaggle. And then we used Google Colab Jupyter Notebook to download that CSV and re-upload into JSON and Parquet format. And we did a comparison and noticed that Parquet was only 15% of the file size when compared to the other formats. So very, very efficient. And then lastly, Emily showed us how to load Parquet data into Jupyter Notebook and do some data analysis and visualization on top of that data. So those are some of the amazing things we learned. All right, let's just catch up on the on the chat there. That's my password. You got it. How did you know? How did you know? Oh my gosh. All right. That's illegal. You need to spell my name correct. It's trademarked. Okay. It's not we. +1 for the chicken keeper. All right, great. All right, so here's how we're gonna do the raffle. If you don't have any more questions. All right, thank you. Thank you for that. All right, so let's comment thanks to Emily for her very first technical stream in the chat. And I'm going to enter names one at a time to our wheel of names. And we're going to do a spin and get our winner. So let's thank Emily for her very first technical stream.
Thank you guys.
Right.
It's very
Thank
fun.
you, everybody. Yes, so we have a lot of names here. This is going to be difficult for me to catch up. Okay, 1 second. I'll have to type them out manually, I think. Is there an easier way? All right, we have so many people commenting their thanks. So let me go ahead and open up a new window here. And do let me know if I missed your name, but I'm going to pop everybody's names into our wheel of names. Let me get my screen share right now. All right, here it is. Okay, everybody, let me put your names in there. Elong. All right, we have a few more. All right, let me know if anyone is still trying to enter.
Avinav says it's too difficult for you to type them, so he won.
All right. Did I do the underscores right? 3 underscores? Let me know. All right. Anybody else? Is this everybody? Let me know in chat right now if I missed anyone. Okay, we'll do a countdown. 10 seconds. Let me know if I missed anyone, if anyone still wants to join in. All right. Since you are here, I'm just gonna give everyone 2 entries to the raffle. Isn't that amazing? Everyone gets 2 entries. All right, here it goes. I'm gonna shuffle a couple times. Let's have a drum roll, please. All right, drum roll, spin. Oh. How did I say this? Giddy? Congratulations. Let me highlight your comment. Our only viewer from YouTube, our Donald Trump from YouTube. Congratulations. Please open a ticket on MLH's Discord server under support tickets. Take a screenshot of this screen right now, and you can claim your surprise prize, which will be mailed to you. Congratulations again. All right, Donald Trump, you won election is also this prize.
I think this prize is the bigger prize.
Agree. All right, so here are some of the resources that we have used throughout this session. We'll also be sharing the slides on the raffle or checking link. Oh, one thing, Giggity, you need to make sure you are checked in on our checking link. We'll have to double check if you're checked in or not. So please be sure you're checked in so that we can award you the raffle prize. He is not. If he's not, I'll rerun the raffle. All right. With that, we have our next session by Cecilia, Sticker Base 2.0 Part 4, which I'm sure Elon's Gardner is going to go to. This is going to be a awesome session wrapping up that project, how to manage your sticker collection. That's happening at 5 p.m. Eastern Time and 3:30. Did I do this right? This should be AM, right? 3:30 AM IST?
I think so, yeah.
Yeah, that was a misspell on my part. I apologize. So be sure to tune in if you're interested. Cool. Any last words, Emily?
I don't think so. Thank you guys for coming. Thank you for all the thank yous in chat. This was a lot of fun.
All right. Well, thank you so much for sticking with us for the past 90 minutes and learning something new. We hope to see you at a future stream at Global Hack Week. Take care, everybody. Bye.